So I'm actually not an architect. I'm an engineer, and I work in human-robot interaction. So how did I become involved in the LAS? So when I first heard about Philip's work, I was very fascinated by this idea of living architecture. So these installations, which I think many of you are already familiar with, consist of a large number of sensors and actuators. The sensors sense both the state of the system itself, these are proprioceptive sensors, and also the state of the surrounding environment. And at the same time, the actuators control the system state. And you can see in this video shape memory alloys that are controlling the movement of the system. And we also have lights that can be turned on and off, and also sound. So to me, this looked like a very large and beautiful robot. So the key design question is, how should the system actuate the actuators in response to its perceptions? So what is the control objective or the control policy of this robot? So with existing systems, the way that this behavior is designed is through the designer. So the designer has a lot of expertise and intuition that they bring to this process. Kind of what is the right thing that the system should be doing? How should it be responding to its perceptions? The challenge, though, is that in order for the designer to do this effectively, they have to be able to kind of visualize the entire system, and they have to imagine the types of behaviors that a visitor in this space would want to engage in. So what we were interested in to look at is whether we could come up with a methodology to come up with these interactive behaviors autonomously. And we were particularly interested to understand whether we could come up with behaviors that are continuously evolving and changing, so that they would be suitable for long-term, kind of lifelong interaction. And we also wanted to better understand what kind of behaviors engage the viewers. So in this talk, I want to talk about both the research and also the methodology for evaluating the algorithms, because I think that's another kind of open question that we need to address. So first, I want to talk about this question of behavior evolution. So in order to allow the system to generate behaviors autonomously, we conceptualize the system as an autonomous agent or a set of agents. We want the system to move from purely reactive behaviors, where the system is always responding to some user or some visitor input, to one where we have a shared initiative. So either the visitor can initiate the interaction, or the system can initiate the interaction. So why would an autonomous system initiate an interaction? The system has to have some internal or intrinsic motivation. We thought about curiosity as an intrinsic motivation drive. So we implemented a kind of computational model of curiosity, and we implemented this on the agent so that the agent was curious both about itself and the surrounding world, and it would generate behaviors to satisfy this curiosity. So this would lead to an autonomous generation of explorative behaviors to satisfy curiosity. And because curiosity is always about exploring things that the system does not know about yet, this would generate different behaviors over time, because as the system generated the same behavior, it would become more familiar with the response to that behavior, and thus its curiosity would lessen, and then it would move on to generate kind of new behaviors that it would be curious about. So we hypothesized that this would lead to a more lifelike exploration. So we wanted to test this idea, so we started by implementing the algorithm, which we called the curiosity-based learning algorithm, CBLA, and also testing it on a physical test bed. So we designed a kind of prototype scale system that was implemented in the LAS studio. And we first started with some initial experiments where we just kind of tried to see what kind of behavior this curiosity algorithm leads to. So we can see here, when the system is initially started, basically the agent is just trying out all of the actions and seeing what happens in response. But when the system is alone, the response is fairly deterministic, right? So if I turn on the light, I can sense that the light is on. And so very quickly, the system becomes bored and enters an idle state, because there's nothing more curious. Everything is predictable. And then, if we have a person entering the scene, all of a sudden, the models that the system has learned become violated, and this now leads to new behaviors being generated to kind of try to explore what is this new thing in the environment that's violating existing models. And you can see that this kind of leads to, it appears that the system is responding to the visitor's presence, but that's not actually what's happened. This hasn't been pre-programmed. It's just kind of an emergent property of the system because it's satisfying its curiosity. So after we kind of implemented this initial, basically kind of a lab experiment, we next wanted to see how visitors to the system would perceive this kind of behavior. So first of all, would this learning algorithm increase the visitor's interest level over prescripted behaviors? Would people be even able to perceive that there's a difference between kind of prescriptive behaviors and a learning algorithm? And then are there certain behaviors that are more interesting than others? So the way that we tested this is we used our prototype system, our testbed system, and we brought in participants. So we ran this as kind of as a standard user interaction study. So we brought in participants one at a time. We had them interact with the system, and then we asked them a bunch of questions through a questionnaire. So this is kind of like a standard HCI, HRI study, but it's really not capturing a realistic scenario of how people would actually interact with the system in the wild. And we also are kind of just looking at a one-on-one interaction. So kind of the actual methodology of the study is rather limited. But what we did find through this kind of study is that some of the visitors enjoyed the interaction and found it quite curious, so that it evoked their own curiosity. But others preferred the prescripted behaviors because they found the curious system kind of unpredictable, and they perceived it to be random. So there was actually the kind of level of enjoyment that visitors had was dependent on interaction between these two curious agents, one human and one synthetic. And if the two levels of curiosity were not synced, the interaction would not necessarily be engaging. So we then wanted to think about, could we actually motivate the system more explicitly to be engaging for the visitor? And we also wanted to move beyond this kind of artificial user study setting. So we wanted to think about whether we could add an extrinsic motivation component so that the system was extrinsically motivated to maximize visitor engagement or interest. So a key question here is, if we want the system to maximize engagement, then the system needs to figure out when are visitors engaged and when they're not engaged. So the system needs to somehow measure user engagement. And we wanted to move beyond this artificial study setting and really see if this would work in a real installation setting where we might have more than one visitor at a time. Those visitors might have different levels of interest, they might have different backgrounds, and so on. So our first question is, how should the system act to maximize visitor engagement? So actually, when the designer is specifying the action policy, this is something that they're keeping in mind already, right? The designer is thinking about what kind of behaviors would be interesting to the visitors. So this is kind of already implicitly contained in the prescripted behaviors. One alternative that we could think about is to just say, okay, we put aside the design that the designer has come up with and just implement a learning algorithm. So if we have this measure of engagement, we basically implement a learning algorithm that tries to maximize that engagement. And we could set this up as a standard reinforcement learning framework. The problem is that typically with reinforcement learning, the agent needs many interactions, needs to collect a ton of data in order to learn appropriately, especially if the number of possible actions is huge, which is the case here because we have a system with many actuators and many sensors. So in order to implement learning in kind of an interactive setting, we need a good low-dimensional representation to enable quick learnings. So we thought, what about if we exploit the designer specification as a starting point for learning? So this gives us a very succinct action state representation that will enable fast learning and also tells us a good starting point. So we start already from a well-designed interaction strategy. Our second challenge is how does the system know when the visitors are engaged or interested? So we've used questionnaires in the past, but they actually disrupt the user experience and are not scalable to crowds. So we wanted to come up with a way to use the existing system sensors to estimate engagement. And because we have kind of low accuracy sensors, rather than estimating individual engagement, we thought about estimating the engagement of the group. And we looked at two measures. One is occupancy, which is basically just if the person is standing around in the space, they are at least somewhat engaged because they're not leaving. And the other kind of better engagement is active interaction, where people are actually raising their hands and physically interacting with the system. And then we wanted to test this in kind of crowded, uncontrolled settings. So we actually implemented this system this fall at the Royal Ontario Museum, together with the exhibit there the Aegis exhibit. So you can see here, this is opening night, and you can see kind of the type of crowds and the system in place. Now, we also had kind of a practical challenge is when we were actually implementing the system. Of course, we couldn't go there during daytime hours. So early mornings and late at night was when we had to come in and actually implement and debug the system. So I just want to show you a couple of quick videos, some of the kind of qualitative findings. So you can see here, actually, social interaction, it was something that was touched on earlier, is key to this interaction. So you can see in this video, there's a person who is very interested in the system, but they don't actually, they are not aware that you can actually interact with the system by raising your hand and activating one of the sensors. And then a person comes in and kind of demonstrates this behavior, and now this gentleman has kind of figured out, oh, there's this whole other way that I could interact with the system. And so actually kind of thinking about the social components of the interaction is rather important. You can see in the bottom video, the type of interaction is very different depending on who is in the scene. So here we have kind of a school group, and you can see that the interaction is a lot more energetic than when it's only adults in the room. And then we were also able to observe kind of novel behaviors that the system learned that were not part of these prescripted behaviors, even though we started from the prescripted behaviors. So you can see here this kind of like a thunder a behavior where many of the nodes are being activated at once in a synchronized manner that was not part of the prescripted behavior. So just to conclude very quickly, some preliminary results, we showed that when we combine the human-designed and the learning actions together, we were able to generate a higher number of active interactions. And what we're thinking about for the future is how we can combine intrinsic and extrinsic motivation and how we can better interact with the designer. So right now, we are exploiting the designer's knowledge, but I think it would be very interesting if we could also give back to the designer, hey, these are the things that we learned, and see if we can also make the design of the behaviors kind of interactive at that level. And we're also still thinking about better ways of measuring engagement, but using, again, sensing that is transparent to the visitors and doesn't impact their experience. So I'll close by thanking all my students and all my collaborators. Thank you.